Okay, so let's take a look at the basic calculations workshop that you're going to do for this particular experiment. And let's just take a look at some of the instructions just to make sure that you're all on the same page. Make sure that you're writing all of your answers in the blank spaces that are provided so that I can actually follow easily where your calculations are at and your answers happen to be whenever grading this assignment. Make sure you also box your answers if there's no line provided, so I know where to look for your answer. Other thing is that you need to make sure you show all of your work. So just writing an answer down on a problem that has a large space for you to show that your calculations won't work, I will count that wrong. So make sure you show your work. When you submit this in the end, make sure that you submit them in alphabetical order. Obviously, you're submitting this stuff online, so don't worry about the staple in that particular respect. When it comes to doing your calculations, I'm going to be paying a very significant portion of my attention to significant figures. So can you actually do calculations using the concept of significant figures? If you're unfamiliar with this, then you need to go back and rewatch some of your lectures on significant figures and ask your tutor or send me some questions via email. You want to use a periodic table that's really any periodic table would be okay. However, the answer key that I have for this particular assignment, I used the periodic table on the back of your lab manual to do so. And those numbers, those atomic masses are rounded to 2 decimal places. And, it's not going to give you significantly different numbers, but it may potentially give you different significant figures if you use a different periodic table. So try to use the one on the back of your lab manual or one that has numbers that are rounded to 2 decimal places. Make sure that you remember that units are a requirement if they are in the problem. So giving me just a number without a unit when a unit is in play in the calculations is incorrect and you will be counted off for that. Also, I want to make sure that you're doing this work, so make sure I see your own handwriting in this particular assignment, whether you've writing your problems in the lab manual and tearing those pages out and submitting them digitally, or you're printing out a copy of this PDF that I've uploaded of the same thing if you haven't bought your lab manual yet. Or if you have some digital way to write on top of a PDF, that's fine. But make sure that I see your handwriting because I don't want to have you guys typing all of the work. That's a little too difficult to do for this particular type of assignment. And also make sure that, I don't care that you're working with someone, but make sure that your work is your work. So show your calculations and do your work. If it's come to light that you have copied someone else's work or you have allowed someone to copy your work, then that's grounds for receiving a 0 for the entire assignment. So don't break that academic dishonesty or honesty kind of policy. It's something you just don't want to do. Okay, so let's move to kind of how the problem will work or how the kind of calculation should be shown. And what I'm going to do is I'm going to just pick maybe a handful of problems to do for you so that you will actually see what I'm expecting from this assignment. And then I'm going to let you guys do all of the rest of the problems. So there are 50 total. You need to complete all 50 for full credit. So I'm going to try number 3 here. And I'm going to do this problem. So I'm going to show my work, and I'm going to just kind of do it right here in the center. I'm going to add my 4 numbers together. And to show my work, obviously you have to do at least the writing down of this problem by longhand. And so I wanted to do this problem just to reiterate to you guys how significant figures works whenever you're adding and subtracting, so the same rules apply whether it's addition or subtraction. Kind of the way what I do is I kind of highlight the last significant digit in each of the numbers, and whichever one's furthest to the left, I put a line behind. So that's the 6 that you see in 13.6. And that means where that line is at, that's the furthest that I can report in significant digits. And so whenever I add this together, you can use your calculator if you want to, if you don't want to do this by adding longhand in case you're afraid of making a mistake. So you can go ahead and add this together on your calculator like this. And so you can write your answer down. And then what you do is you use the number behind the line to round the number in front of the line. And so that's going to just stay as is. So this 149.1. And there are no units for this number. So there you go. So that's how you would do that and how you would show your work and that kind of thing. So what I might do is just show you maybe one more like unit conversion, and then I might go and do one more problem just so you can kind of see this. So I'll do number 8 here. And this particular one is one that happens to have units that are cubed. So anytime you have a unit that's in an exponent, when you're converting from one type of unit to the next, you have to take into account those exponents. So before you think about those, the cubing, let's just think about how do we go from inches to just feet, inches to feet. So we already know a conversion factor, 12 inches is equivalent to 1 foot. So there you go. So you've already got at least the name of the unit down. Now we need to take into account the cubing. So all you do is cube each side of the unit, and there you go. Now another way to write this to keep in mind as well is that the fact that the cube is for the number and the unit. So you're cubing the number and the unit. So this really looks like 12 cubed inches cubed equals 1 cubed feet cubed. So use this form of kind of the conversion factor to make sure that you're putting the correct kind of components into this dimensional analysis problem. So I take 153.75 inches cubed, and then I'm going to take my 12 cubed inches cubed and convert that to feet cubed. And my inches cubed will cancel out, and then you just do your problem here. So if you take 153.75, and you can multiply times 1 cubed, which is just multiplying by 1, which is 153.75. And then you could divide by 12 cubed. And there you go. So that's your answer. So you want to write this number in the appropriate number significant figures. This has 5. These are exact, so you won't use those in that determination. So we're going to put our answer in 5 sig figs. So 0.0889766, and then the correct unit is feet cubed. So that's how you work that kind of problem. So the rest of these are all kind of just basic, conversions of temperature or other units. You have some problems that use just basic percentages, or this number 23 is a unit conversion. It's just written in word form, kind of starts you out. It looks something like this. So dollars per gallon, you want to actually convert that to cents per liter. And so treat each unit like the dollar, convert dollars to cents first, and then go back and convert gallons to liters. And so it's really just 2 unit conversion problems all in one. Density, here's nomenclature, how to show your work on nomenclature, like for copper 2 fluoride. The formula or the symbol for copper is Cu. The 2 means it has a +2 charge, and then you have fluoride is the F minus 1. And then you just balance the 2. You have however many atoms of each in order to balance the charge to be 0. That means you need 2 fluorides, so it's CuF2. And so that's how you'd show your work on that. For the rest of these problems, so that here you would have formula mass, and here's an example that you can see here for how to do that. The hydrated problems are problems where it's formula mass of a substance plus the formula mass of water, and you multiply that formula mass by how many waters you have, and then you add the two together. So this little dot means a plus. So you're going to add all of the formula masses of everything together, and that will be your answer for that. And then you've got a couple problems, like a lot of the rest of these problems are percent composition useful type problems. And so essentially what you're wanting to do is say if I have 9 carbons, what's the atomic mass of all of the 9 carbons divided by the entire formula mass of the entire substance times 100. And that will give you the percent of carbon. And then you go through and do that same thing for hydrogen. So it would be eight hydrogens over the entire substance times 100 to give you percent of hydrogen. And then you do the same for oxygen. And so percent compositions are pretty easy. You can also use those to figure out what the formulas happen to be. The empirical or molecular, and there are examples of how to do that in your lectures. And then the last section of this particular workshop goes through how to calculate things like molarity. And if you remember, molarity is a concentration that's calculated as moles of a substance divided by the liters of that solution that substance is made of. And so in this particular case, the moles for this would be 6.00 moles of HCl divided by the total volume of the solution, 2.50 liters of solution. And so you would do this math, just 6 divided by 2.5, and then make sure that you're writing this number in the appropriate number sig figs based on your values in your problem. And that's going to be 2.40. So we need to make that 3 sig figs, and then you would call that molar HCl. So this whole section right here, you would write as the capital M, and we say it molar. And then you would say of what substance, and that's how you put the formula behind that. And so, this is the next couple of problems would be how to do molarity, and then the last two are going to be dilution problems where you'll use C1V1 equals C2V2, and you just plug any 3 values that you have into the formula and solve for the 4th one, and make sure you're doing that in the appropriate units. So this is the calculations workshop. Make sure that you're doing all the 50 problems. Each problem is worth about 2 points apiece. And so if you have any questions, just let me know, contact the tutor, and that's it. All right.